All right, 10.2, the area of circles and sectors of circles. So let's talk about this. First of all, the area of a circle. This is a formula you're probably familiar with. It's simply pi r squared. But let's talk about where that comes from. This is just an example. To really get this perfect, you'd have to slice a circle into infinite little pi slices. But for argument's sakes, we're just going to slice it into the ones we have here. Basically, if you sliced a circle up a bunch of times and then rearrange those pieces, you could rearrange them into a parallelogram that would look something like this. Now, I see that there's still a curve here, and so I know it's not a straight line. But if you were to theoretically slice this into infinite pieces, you could theoretically have a straight line here. Now, this then becomes just a parallelogram. And we know that the area for a parallelogram is simply base times height. Well, the base here, as you can see, would be pi times r, and the height would be r. And so we get the formula pi r squared. And there's other ways to demonstrate this area as well, but this is just a really simple way to show you where this formula came from. So, knowing that, let's do some calculations. It says, find the area of the circle with the following conditions. Leave your answer in exact terms. Well, right away, they're asking for it. They're giving me diameter, but if they want area, I need to find the radius first. So if the diameter is 8, then the radius is 4. Now, there should be units here. There's not, so I'm just going to say units. So area equals pi. My radius is 4 squared. So that means 4 squared is 16, so I would just write 16 pi, and I would write units squared. All right, that's all there is to it. So go ahead on practice number 1 and try and calculate the area of a circle with a radius of 6. All right, so you just plug a 6 into the formula. 6 squared is 36, and so you have 36 pi for your area, and that's all there is to it. Let's go to the next page. Alright, so we got a small word problem here, no big deal. A caterer has a 48-inch diameter table with that is 34 inches tall. She wants a tablecloth. Let's cross off that 2 there, that's a typo. She wants a tablecloth that will touch the floor. Find the area of the tablecloth. Before we could find the area of the tablecloth, we have to find the radius. So let's zoom in on the picture here. This is our whole tablecloth here, and this is just the tabletop. Well, if the diameter of the tabletop is 48, then its radius is 24, which would make the radius of the whole tablecloth 24 plus 34, which is 58 inches. Well, now that we know that, we could find the area. The area of the tablecloth has to equal pi times the radius squared. Well, now we know the radius of the tablecloth is 58, so 58 squared. 58 squared is 3,364 pi inches squared. So there we go. And we're done. So now let's talk about finding the area of a sector. So in order to do that, we need to talk about what a sector is. Basically, a sector is just a section of a circle. So here you see the little pizza slice of a circle. That is a section of the circle. And in this drawing, the A here is supposed to represent angle. And since we stopped using A for angles, I want us to just cross it off and put a theta symbol, because we've been using that for angle. And basically, if you have some area of a sector, if you want to find the area of a sector, it's going to be proportional to the area of the whole circle in the same way that the angle is proportional to the whole circle. So if you have a central angle in degrees, you simply put the central angle over 360 degrees, and that would be equal to the area of the sector over the area of the whole circle, and that's where the pi r squared comes in. If it's in radians, then instead of doing it out of 360, you just do it out of 2 pi, because 2 pi represents a whole rotation through a circle. Pretty much, other than that, it's the same formula. It's just, if it's in degrees, put it over 360. If it's in radians, put it over 2 pi. So let's go ahead and play with this. We're going to find the area of the sector using these formulas. Looks like we're starting off using degrees, so I'm going to use this top formula here. and we're going to zoom in. So my central angle is 100, so I'm going to put 100 over 360 equals, I want the area of the sector over the area of the circle. They already gave me the area of the circle. I don't have to figure it out, so it's just 50 pi. Well, I could definitely reduce some things here. I could cancel out a 10, and I can also take a 2 out of both 10, which gives me 5, and 36, which gives me 18. So let's rewrite this. It's like saying 5 over 18 is the same thing as the area of my sector is over 50 pi. Well, I want to get the area of the sector all by itself, so I multiply both sides by 50 pi. These cancel. And now I have a 50 times pi over, or times 5 all over 18. Well, again, I could take a 2 out of 50, giving me 25, and take a 2 out of this, giving me 9. And so I have 25 times 5 times pi, which is 125 pi over 9, and that equals the area of the sector. Now again, this should be in units squared, but I know there was no units here other than degrees, so we would just leave it in units squared. All right, so practice number 3 is very similar, only this time it's in radians, so you're going to use the formula for radians. Go ahead and give it a shot, and I'll put the answer up there in just a second. Alright, so I started off by putting my central angle, which is 3/5 pi, over 2 pi, setting equal to the area of the sector over 100 pi. Right away I saw I have a fraction over another number, so I made 2 pi to 2 pi over 1, and then I flipped and multiplied, so that's 1 over 2 pi. The pi's canceled out, so I had 1 times 3 over 2 times 5, which is 3 over 10. And over here nothing changed. Then I multiplied both sides by 100 pi, and I saw that I could take a 10 out of both of these, so that's where that 10 came from. So on the bottom I don't have anything, I just have a 1, and I have 10 times pi times 3, which is 30 pi. So the area of the sector is 30 pi. Again, units squared. I know there's no units in here, so we would just put units squared, whatever those units are. All right. Now we're going to actually find the area of the circle. So they're going to give us the area of the sector, and we're going to solve for the area of the circle. So let's plug it into the formula. This time it's in radians, so I'm going to start off with 15 over 9 pi all over 2 pi is equal to the area of the sector, which I know is 15 pi over 2 over the area of the circle. Okay, a lot of crazy stuff going on here, right? We got fraction on top of a whole number, fraction on top of some number. What can we do? Well, remember, we can make this into a 2 pi over 1 and flip and multiply. So this could really be like 1 over 2 pi, and then we could get rid of this whole bottom. Once we do that, I see that I have a pi on bottom and a pi on top, so things start simplifying right away. I can actually do the same thing to the other side here. I can make this the area over 1, flip and multiply, make this 1 over the area of the circle, and I could get rid of that. This is going to be helpful. Watch, take a look. When we go to simplify everything, again, on top I just have a 15, so I'm going to come over here. 15 over 18 equals 15 pi over 2 times the area of the circle. And I'm just going to leave that as A for now. We know we're talking about the area of the circle, so I don't have to keep writing AC. Okay, I think that this reduces because I think we could take a 3 out of both of these. I should have seen that earlier. So if we take a 3 out of this, we get 5. If we take a 3 out of this, we get 6. So let's rewrite it one more time. It's 5, 6 equals 15 pi over 2a. At this point, there's a few different ways we can solve it, but probably the way you're most comfortable is just cross-multiplying. If we cross-multiply, 6 times 15 is 90 pi equals 5 times 2 is 10 times the area. One last step, divide both sides by 10. And we could cancel out the 10s, and we get the area of the circle is 9 pi. And again, whatever the units are, it'd be units squared. Okay, so we found the area of the circle. It's 9 pi. All right, I want you guys to try practice number 4 on your own. This one's in degrees, so it should be a little bit easier. Go ahead and give it a shot. All right, so I simply reduced, I set up the equation 120 over 360 equals 25 over the area of the circle. I reduced, so I got 1/3 equals 25 over the area of the circle, cross multiplied. I got 75 pi, again it's unit squared, equals the area of the circle. All right, last one here. We have a little, like, I don't know, maybe a pie graph you could call this. And we want to know the area of the top sector if the diameter is 12. And let's make it interesting here. Let's go ahead and give it a distance. Let's say that this is 12 centimeters. So first we're going to find the area of the top sector. No big deal. We know the formula to do that. I'm going to start over here because I might need that room. So again, the top sector that we're talking about, just to be clear, is this top sector, the blue one, okay, 46 degrees. So let's write out our equation. It would be 46 degrees over 360 degrees equals the area of the sector, which we don't know, over the area of the circle, which we also don't know, but we can find because it's pi r squared. I'm leaving the r blank because if we go back and look at the circle, we see that the diameter is 12, therefore the radius must be 6. So I'm going to plug in a 6 here. All right, let's see if we can clean this up a bit. I think I could take a 2 out of both of these. So I would get 23 over 180 equals, I'm just going to put area for area of the sector now. We don't have to label with the S every time. Over 36 pi. Okay, I think I can multiply both of these by 36 pi. 36 pi. Cancels, cancels. Now, is there a number that goes into both 36 and 180? There certainly is. It's actually 36. So 36 goes into itself once, and it goes into 180 5 times. So we can let this simplify. We could say that the area of the sector is equal to 23 pi over 5. And we do have units this time. Remember, the units were centimeters, so that means this is going to be centimeters squared. Okay, that was just part A, though. We found that. The next thing is find the probability that a point chosen at random lies in the top sector. Okay, so here's the deal with probability. All it is the area or the percentage of a space over the whole thing, which if it was percentage would just be 1, or over the whole area. So there's actually a few different ways we can do this. We could do the area of the sector over the area of the whole circle, but we already know what that proportion is equal to. We said so here. We said the area of the sector over the area of the circle is equal to 46 over 360. And so we're allowed to do that. We could just say then it has a probability of 46 out of 360. And again, if I was to reduce that, that would be 23 out of 180. And so that is a fraction that represents probability. Now, if we wanted to get a decimal answer for that, which usually we do with probability, we could just go to our calculator and do 23 divided by 180, and we'd get that that's 0.127 repeating. Or, if we were to convert that to a percentage, 12.7 repeating percent. And so that's typically how we write probability. We usually talk about it in percentage. And so we could say if we chose a point at random here, there's a 12.7 or 7 repeating percent chance that it would land in the blue area. All right, fun problem, guys. Let's go to the next page. Okay, so here all I want you guys to do is compare and contrast the formula for the area of a sector to the arc length formula we learned last chapter. How are they similar? How are they different? Think about that. Key word here is proportions.